Hello and welcome to Slooh, the Community Observatory. I'm Paul Cox and we are watching live images of the Juno spacecraft as it slingshot around the Earth on its journey to the fascinating gas giant planet Jupiter. Now the images are coming direct from Slooh's half-meter telescope located in the Canary Islands. World-class observatory facility which is run by the Instituto de Astrofísica de Canarias. They're partners of ours. They're wonderful people. Now, if you have any questions during the show, just use a Twitter hashtag at Slooh, and we'll try and get those to our special guest. Now, without further ado, let's find out more about this amazing space mission as Juno is flung Earth for the next leg of, I believe, its 1.7 billion mile trek to discover the secrets of Jupiter's interior. And to help us do that tonight, I am delighted to introduce our special guest this evening, Dr. Steve Levin, who's the Juno project scientist at the Jet Propulsion Laboratory and recipient of the NASA Exceptional Achievement Award medal last year. So good evening, Steve. Huge thanks for joining us on what must be an incredibly hectic day there at JPL.
Oh, my pleasure. And I'm actually joining you from Denver because I'm with most of the science team. We've gathered here in Denver. A lot of people are already in town for a meeting, so this was a good place to get together during the flyby.
Excellent. Now, Jupiter is by far the largest planet in the solar system, but we know surprisingly little about it, don't we? So could you give viewers a kind of brief overview of the Juno mission?
Sure. My pleasure. Of course, one of my favorite subjects. So Juno's on Jupiter. You mentioned, even though Jupiter is 300 times the mass of the Earth and more massive than all the other planets combined, and we've studied it for hundreds of years, we still don't know very much about what lies beneath the clouds at Jupiter. So we need to know some basic things like, is there a central core to Jupiter? We believe there's an ocean of liquid metallic hydrogen that generates Jupiter's enormous magnetic field, but details about the size of that ocean and whether there's a core in the middle and the motions of the liquid and so forth that generate that magnetic field still remain unknown to us. The basic structure of the interior of the planet is unknown to us. We see these belts and zones whipping around the planet like giant jet streams. All of that, or almost all of that, is the result of the fact that we can't really see beneath the clouds in the top of Jupiter's atmosphere. So Juno's job is to solve that problem for us. Our spacecraft is going to orbit Jupiter in a polar orbit, so it'll come over the poles of Jupiter, dive down underneath Jupiter's massive radiation belts, so between the radiation belts and the planet, and at the equator of the planet it will come very close to the planet, a few thousand kilometers above the cloud tops, and then go zipping off into orbit, 11-day orbit. So it'll take a couple hours to come flying by Jupiter, then be 11 days in a big long orbit around, and then come back again every 11 days for a year. In the meantime, with Jupiter rotating every 10 hours, by adjusting the timing just a little bit of each of those orbits, we can get a new longitude stripe. So we'll wind up making a map of the entire planet, and we'll use gravity, because gravity comes from the entire planet, to learn about the interior. The magnetic field, because the magnetic field comes from how did the giant planet form. One of the pieces of information you really need to know is how much water is there in the interior of Jupiter. So we'll measure that as well. From all of that, by learning about the inside of Jupiter, we hope to learn about the origin of the planet, which teaches us about how planets form, how solar systems form, and ultimately, of course, where do we come from?
You know, Steve, this is what fascinates me about astronomy and space exploration. Whenever we think we've learned something new, we find out actually that there's still this huge swathe of absolutely fundamental knowledge that we have no idea about. So I'm really looking forward to the results of the Juno mission. But, you know, you were mentioning gravity there. Now, Juno was launched in 2011. So it's been around a bit already, and I believe it's already traveled out beyond the orbit of Mars. So why did it come back home for tonight's gravity assist maneuver?
So the short version of that is we did not have or could not afford a big enough rocket to launch Juno with enough energy, enough speed to get all the way out to Jupiter. So we're using a technique called a gravity assist, where we launched it with as much speed as we could manage in the right direction. So it now is orbiting the sun. As you say, it went out past the orbit of Mars. Then we fired the engines on Jupiter all the way out to Jupiter. So that took place earlier today.
A well-practiced maneuver, because I believe Voyager 1, Voyager 2, was it Galileo as well?
Galileo did that as well.
Yeah.
I think a couple of other spacecraft, Messenger did that. It's relatively rare to use the Earth for that flyby maneuver, but it's not unheard of. It's been done a couple of times before. And the basic idea is you have a moving object out there in space, so if you can latch onto it for a little while using its gravity, that gives you a boost. It's sort of like coming up behind a truck moving on the highway and grabbing onto the truck for a bit to get some extra speed.
I can see the kids doing that straight away. So how did
operation of the instruments and making sure everything's working perfectly and so forth. We also took some pictures and things like that. We don't have all of that data down to the ground yet, but I expect to see some fun things.
Excellent. Well, we'll be keeping a close eye on that. And actually, I've got a show on Friday, so I will give a little update what's happening to Juno today about that. We have some questions coming in, Steve, if you wouldn't mind asking these. And the first question has actually been the one that's been most asked, and that is, how has the US government shutdown affected the mission at such a critical time?
Well, the good news is that because of the nature of what we were doing, we were granted an exception to the shutdown. So the people who were necessary to make sure that the spacecraft is safe and we collected the data we need to collect and so forth, were all allowed to keep working. The bad news from the point of view of the government shutdown is that anything to do with press releases and sending the information out to the public and so forth is not considered part of that essential activity that granted an exception. So all of NASA's usual procedures for letting everybody see what we're doing is shut down, and the word's getting out a little bit. We're able to tell people through avenues like this and through some of the people who work with us, but the real release of here's everything that we did is going to have to wait until the government's operating again.
Well, I know we've got viewers from around the globe this evening, so hopefully Slooh are doing a little bit to kind of offset the lack of PR. I've got another question here, and it's one which is kind of fascinating and kind of a little bit sad to me, really. And it's just asking, what's the ultimate fate of the Juno spacecraft? And I think, Steve, this is not good news for Juno, but it's good news as far as Jupiter's concerned when it comes to any contamination threat, isn't it? So what's going to happen to Juno at the end of its mission?
So at the end of our year at Jupiter, the Juno spacecraft is going to be crashed into Jupiter, essentially. We're going to burn up in the upper atmosphere. Remember, Jupiter is mostly atmosphere. And the spacecraft, we're going to fire the thrusters so that the last close approach to Jupiter, the last perijove pass, instead of zipping past the planet, we will skim into the atmosphere and burn up. And the reason for doing that is that, among other things, one of the moons of Jupiter, Europa, has a liquid water ocean underneath the ice. And people would love to go there and look to see if there's any possibility of life in that water ocean. But you'd hate to go 25 or 50 years from now, after doing a lot of work with a spacecraft to Europa, burrow down into...
Another question, actually, I've got it here. It was, how is the Juno mission team going to protect the sensitive electronics from Jupiter's radiation belts?
So I'll mention that in a minute, but let me just finish then. Then, because the electronics will eventually die, we have to make sure, while we still control the spacecraft, that we do something to make sure it doesn't hit Europa, and so we'll crash it into the upper atmosphere. But our electronics are protected partly because we encase all of the really sensitive stuff in a big metal vault. So we call it the radiation vault, and it's made out of titanium, sort of like putting your brain in a helmet as you're driving down the highway. And partly because we've chosen our orbit very carefully to dive under the radiation belts. Previous spacecraft that go to Jupiter, and there have been a few, have generally tried to stay well outside the radiation belts. So we're either braver or perhaps not as smart as that, and we're diving underneath the radiation belts. That another reason why it's okay to destroy poor Juno and drop it into the upper atmosphere is that even if we did not do that, within a few orbits more than the end of the mission, we'd be flying right through the radiation belts and completely destroying the electronics. So we know that there is not a big extended mission for Juno that would be possible, and therefore it's okay at the end of the mission, while we still have control, to dive into the planet.
Thank you. That's just about time to wrap the show up, I'm afraid. So it's actually, I must just say that still on the subject of Jupiter, we have a spectacular show planned for Friday night. We'll be broadcasting a rare triple transit of Jupiter's moons as they pass in front of the giant planet. So please join us for that show, and keep an eye on the Slooh homepage, where our live events are always counting down. Now, special thanks this evening to Dr. Steve Levin from JPL for sparing the time to join us tonight on such a special day. I'm so glad you were able to join us to share some of the information about the Juno mission. Slooh members, we're certainly going to be following the Juno mission from now until 2016 is arrival date. Is that correct? July 4th?
July 4th, 2016, although I think at Tenerife, at the Slooh Observatory, it might be July 5th by then.
It is, actually, but I didn't want to say that. It's because it's 0230, but everywhere it's plastered saying the 4th, and I knew that if I said the 5th, we'd get lots of emails coming in. But yes, so anyway, we will be watching the outcome of the Juno mission with great interest. We wish you, Steve, and the mission team every success, and we wondered whether or not you'd pop back from time to time to keep us updated on the fascinating mission. And I guess it's next stop, Jupiter, July 5th, 2016.
That's absolutely right, and I would love to pop in from time to time to continue the conversation.
Excellent. Well, thank you very much indeed, Steve. So it's good night from me. This has been Paul Cox from the Slooh Community Observatory, and I'm off to watch some live images of Comet Ison with other Slooh members. Good night, everybody. Hello and welcome to Slooh, the Community Observatory. I'm Paul Cox and we are watching live images of the Juno Spacecraft as it slingshot around the Earth on its journey to the fascinating gas giant planet Jupiter. Now, the images are coming direct from Slooh's half-meter telescope located in the Canary Islands. World-class observatory for facility, which is run by the Instituto de Astrofísica de Canarias. They're partners of ours. They're wonderful people. Now, if you have any questions during the show, just use the Twitter hashtag at Slooh, and we'll try and get those to our special guest. Now, without further ado, let's find out more about this amazing space mission as Juno